Hello, everyone. My name is Dr. Khan. Thank you for being here today. It is my pleasure to introduce an exciting and transformative topic, artificial intelligence in smart cities, shaping the future of urban living. As urban populations continue to grow, cities worldwide face increasing challenges related to infrastructure, sustainability, mobility, and public services. The integration of AI offers a revolutionary approach to addressing these urban complexities, creating efficient, sustainable, and livable cities. Smart cities are urban environments that integrate artificial intelligence, AI, the Internet of Things, IT, and big data to improve infrastructure, public services, and sustainability. The goal is to enhance efficiency, sustainability, and quality of life for residents through advanced technology-driven decision-making. AI plays a fundamental role in smart cities by collecting and analyzing vast amounts of data in real time, allowing government agencies, city planners, and private sector partners to optimize city operations. A 2021 McKinsey study suggests that AI-driven solutions can reduce commute times by 20 to 30%, lower crime rates by 30 to 40%, and decrease water consumption by 15% in urban areas. Key elements of smart cities include modern infrastructure, data-driven decision-making, and citizen engagement. Successful implementations in cities like Singapore, Amsterdam, and Barcelona have demonstrated the benefits of AI-powered smart cities by enhancing energy efficiency, optimizing transportation, and improving emergency response times. Despite its advantages, transitioning to a smart city requires significant investments in digital infrastructure and regulatory frameworks that prioritize data privacy, cybersecurity, and ethical AI deployment. Governments and private entities must collaborate to ensure transparent and inclusive smart city strategies that cater to all citizens. AI is transforming urban infrastructure by automating processes, improving efficiency, and optimizing resource allocation. AI-driven urban infrastructure enhances various sectors, including transportation, waste management, energy grids, and water systems. One of the most impactful AI applications is predictive maintenance, where AI-powered sensors detect infrastructure weaknesses before they escalate into failures. According to Gartner, predictive maintenance can reduce infrastructure costs by 20% and increase asset lifespans by 30%. Another area is AI-powered water management, where machine learning models analyze consumption patterns, detect leaks, and optimize water distribution. Cities like Tokyo and Amsterdam leverage AI to improve water conservation, reducing wastage by 15 to 20%. Smart waste management is also gaining traction. AI-driven waste bins equipped with IT sensors notify collection agencies when bins are full, optimizing collection routes and reducing waste disposal costs by up to 40%. San Francisco's AI-driven waste management program has been particularly successful in this regard. However, a key challenge remains cybersecurity. With AI-integrated infrastructure, urban systems become potential targets for cyber attacks. Cities must implement robust cybersecurity frameworks to safeguard critical infrastructure from breaches and data theft. AI is reshaping urban mobility by optimizing traffic flow, reducing congestion, and enhancing public transportation. AI-powered smart traffic management systems analyze real-time data from cameras, sensors, and GPS to provide dynamic traffic adjustments. Smart traffic signals powered by AI adjust signal timing based on traffic flow, reducing congestion. A McKinsey study found that smart traffic lights can decrease travel times by up to 25%. AI-driven traffic monitoring provides real-time insights on congestion patterns, allowing cities like London and New York to optimize road networks and improve traffic flow. AI-driven models also help predict accident-prone areas, enabling proactive interventions to reduce road incidents by 30 to 40%. However, ethical concerns arise regarding privacy and surveillance in AI-powered traffic management systems. The collection and analysis of vehicle data must comply with data protection laws and ensure transparency in how data is used. AI is at the forefront of sustainable energy management in smart cities, facilitating real-time monitoring, conservation strategies, and renewable energy integration. Smart grid management powered by AI enhances energy distribution by balancing supply and demand. AI based grid forecasting helps reduce power outages and optimize electricity costs by 15 to 20%, according to McKinsey. AI also integrates renewable energy sources such as wind and solar into smart grids, improving energy efficiency. Cities like San Diego and Copenhagen use AI powered models to predict and manage fluctuating renewable energy supply, reducing dependence on fossil fuels. In building energy management, AI optimizes energy consumption, reducing energy waste by 30 to 50%. Singapore's AI powered Green Mark program is a leading example of smart building technology that improves energy conservation while maintaining efficiency. Challenges in AI driven energy management include high implementation costs and cybersecurity risks. Governments must develop policy frameworks that encourage investment while ensuring secure deployment. AI driven security solutions enhance crime prevention, emergency response, and real time surveillance. Predictive policing models analyze crime data to identify high risk areas, enabling proactive law enforcement. AI based crime forecasting has been shown to reduce urban crime rates by 20 to 30%. AI powered surveillance systems use facial recognition and behavior analysis to detect suspicious activity. While beneficial for security, these technologies raise privacy concerns, requiring strict ethical and legal oversight. Emergency response optimization leverages AI to analyze real-time incidents, prioritizing responses and dispatching emergency teams efficiently. Studies suggest AI-based emergency systems can reduce response times by 35%. However, AI's role in public security must be carefully regulated to prevent over-surveillance and ensure civil liberties are protected. AI is revolutionizing urban planning by enabling data-driven zoning, infrastructure expansion, and green space allocation. AI-assisted city planning utilizes data analytics to optimize road networks, residential zones, and public facilities, ensuring balanced urban development. AI also enhances citizen engagement through digital governance platforms, allowing residents to report issues, access public services, and participate in decision-making. Barcelona and Toronto have successfully implemented AI-driven citizen engagement initiatives that improve transparency and accessibility. As AI adoption increases in smart cities, ethical challenges arise, including bias in AI decision-making, data privacy concerns, and cybersecurity threats. Algorithmic fairness is crucial, as biased AI models can disproportionately affect marginalized communities. Cities must ensure AI applications are tested for fairness and equity. Data privacy remains a significant issue, requiring governments to establish clear data protection policies and cybersecurity protocols to safeguard personal information. AI-powered applications in smart cities rely heavily on data collection, processing, and analysis. Building a robust data infrastructure is essential to ensure AI systems function efficiently and accurately. Smart city AI models require vast amounts of data from sensors, IT devices, and real-time monitoring systems to optimize urban services. A strong data infrastructure ensures that AI-powered transportation, energy grids, and security systems can process information in real time, leading to faster decision-making and enhanced urban operations. According to McKinsey, cities that invest in AI-driven infrastructure can reduce operational inefficiencies by 20 to 30%, leading to cost savings and improved service delivery. However, data silos and interoperability issues between government agencies and private tech firms remain a challenge. Establishing standardized data sharing policies will be crucial to maximizing AI's benefits in urban development. As cities become more dependent on AI, cybersecurity threats are a major concern. Protecting AI systems from cyber attacks and data breaches is paramount to ensuring trust, privacy, and functionality. AI systems collect sensitive data from citizens, businesses, and critical infrastructure, making them prime targets for hackers. A Gartner report predicts that by 2026, cyber attacks on smart city infrastructure will increase by 35%, underscoring the need for stronger AI security protocols. AI-driven cybersecurity solutions can detect and mitigate cyber threats in real time, but the risk of data manipulation and AI-driven misinformation remains a challenge. Governments must implement strict cybersecurity frameworks to protect against data breaches, system manipulation, and AI-generated fraud. Addressing cybersecurity risks will require a multi-layered security approach, including encryption, AI-based threat detection, and cross-sector collaboration between public and private entities. The successful adoption of AI in smart cities depends on public trust and acceptance. Without community engagement and transparency, AI-driven initiatives may face resistance. AI surveillance, automated decision making, and predictive policing raise ethical concerns regarding privacy, fairness, and accountability. A recent study by the World Economic Forum found that 40% of citizens are skeptical of AI's role in governance, citing concerns over bias, transparency, and decision making control. Governments and tech leaders must educate the public on the benefits of AI in smart cities while also addressing concerns related to data privacy and algorithmic bias. Citizen engagement platforms, AI ethics committees, and transparent AI policies will be critical in building public trust. Public involvement in AI implementation through consultations, surveys, and participatory decision-making processes will ensure that AI technologies align with citizen needs and ethical standards. As we conclude our discussion on AI in smart cities, let's take a moment to reflect on the key takeaways from this presentation. AI is not just a futuristic concept, it is actively shaping the way our cities function, making them more efficient, sustainable, and citizen-centric. AI has the potential to revolutionize urban life, but its success depends on responsible implementation, strong governance, and ethical considerations. As cities continue to adopt AI-powered solutions, policymakers, businesses, and citizens must work together to ensure that AI serves the public good while addressing risks related to privacy, bias, and security. Looking ahead, the future of AI in smart cities is exciting yet complex. Emerging innovations such as autonomous transportation, AI-driven climate resilience, and next-generation IT integration will further enhance urban ecosystems. However, proactive governance, inclusive urban planning, and continued investments in AI literacy will be essential to realizing AI's full potential. As you leave the session, I encourage you to think and comment about the role AI can play in your own city or industry. What opportunities exist for AI-driven improvements? How can AI be leveraged responsibly to create a better urban future? Thank you for participating in this training video. I appreciate your time and engagement, and I look forward to seeing you in our upcoming sessions.